Hey everyone, in this video we shall see the topic sampling distribution of the difference between two means. Sampling distribution of difference between two means. Suppose we have two populations. The first population is of size n1 with mean mu1 and standard deviation sigma 1, and the second population is of size n2 with mean mu2 and standard deviation sigma 2. Then the difference between the population means of the sampling distribution is denoted by mu x1 bar minus x2 bar, which is mu1 minus mu2. The standard deviation of the sampling distribution of difference of mean is sigma x1 bar minus x2 bar equal to root of sigma n1 square by n1 plus sigma 2 square by n2. The standard normal random variable z is z equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by root of sigma 1 square by n1 plus sigma 2 square by n2. Now let us see a problem. Strength of wire were produced by company A has mean of 4500 kg and a standard deviation of 200 kg. Company B has a mean of 4000 kg and standard deviation 300 kg. So here we have two companies A and B. Company A is the first population and company B is the second population. Here it is given that company A has mean 4500. It means mu1 value is 4500 and standard deviation is 200 for company A. So we have sigma 1 value is 200. Now the second population has mean 4000 and standard deviation 300. It means mu2 value is 4000 and sigma 2 value is 300. Next in question it is given that if 50 wires of a company A and 100 wires of company B are selected at random, it means first population has size, that is sample size n1 is 50 and second population has n2 value as 100. Now we have to find the probability that the sample mean strength of A will be at least 600 kg more than that of B. Now the sampling distribution of the difference between two means is mu x1 bar minus x2 bar is mu1 minus mu2. Here mu1 value is 4500 and mu2 value is 4000. So we have mu x1 bar minus x2 bar value is 500. Now the standard deviation sigma x1 bar minus x2 bar is root of sigma 1 square by n1 plus sigma 2 square by n2. Here sigma 1 and sigma 2 values are 40,000 and 90,000 and n1 n2 values are 50 and 100 respectively. By substituting we have sigma x1 bar minus x2 bar value is 41.231. Now the probability x1 bar minus x2 bar greater than 600 is P of x1 bar minus x2 bar minus mu1 minus mu2 divided by root of sigma 1 square by n1 plus sigma 2 square by n2, which is greater than 600 minus 500 by 41.23. So which is equal to P of Z greater than 2.43. So which can be rewritten as 0.5 minus P of 0 less than Z less than 2.43. From the table of normal distribution, we have P of 0 less than Z less than 2.43 value is 0.4925. So we have the probability value as 0.0075. Now sampling distribution of the difference of two proportions. Here the mean of the sampling distribution is represented by mu p1 minus p2, which is p1 minus p2, and the standard deviation of the sampling distribution is represented by sigma p1 minus p2, which is defined as root of p1 q1 by n1 plus p2 q2 by n2, and the standard normal random variable is z equal to p1 minus p2 minus capital P1 minus P2 by root of P1 Q1 by N1 plus P2 Q2 by N2. Now let us see a problem. In two proportions, 10% of machine produced by company A are defective and 5% of machine produced by company B are defective. So here also we have two populations, company A and company B. It is given that in company A, the defective product is 10%. So we have P1 value is 10%, which is 0.10. And in company B, the defective is 5%. So we have P2 value is 5%, which is 0.50. Next, it is given that a random sample of 250 machines are taken from company A and has a random sample of 300 from company B. So the corresponding N1 value is 250 and N2 value is 300. Now we can find the value of Q from P1, sorry, Q1 from P1, that is we know the relation between P and Q, that is P plus Q is 1. So using that relation we have Q1 value is 1 minus P1, which is 0.90, and Q2 value is 1 minus P2, which is 1 minus 0.505, which is 0.95. Now the mean mu P1 minus P2 is 0.10 minus 0.05, which is 0.05. Similarly, sigma p is root of P1 Q1 by N1 plus P2 Q2 by N2. Here P1 and P2 values are 0.10 and 0.05 respectively. Q1 Q2 values are 0.90 and 0.95 respectively. And the samples N1 N2 values are 250 and 300. So by substituting the values, we have sigma p equal to 0.0228. So the required probability P of P1 minus P2 less than or equal to 0.02 value is P of Z less than or equal to minus 1.32, which can be rewritten as 0.5 minus P of 0 less than or equal to Z less than or equal to 1.32. Now from the table we have P of 0 less than or equal to Z less than or equal to 1.32 is 0.4066. So the probability is 0.0934. Thank you.